So let me show you what we're looking at in GitHub. Okay, let me pull up the browser, show you in GitHub, and notice this is the one that says Team City Demo. Okay. All right. So we have this particular Git repository, which, if this is interesting at all, I highly encourage you to clone this repository. It comes with a very extensive README file. Okay. And with this README file, you see the scroll bar. It is step by step how to implement this in your own environment. So let me just go back to the top. You see we have configuration as code folders for GitHub, Octopus, Team City, and then we have the Azure Pipelines YAML here as well. And with this and with the instructions, all you need is your own Team City Cloud account, which you can get a free trial, register for your own Octopus Deploy Cloud trial account, again, easy. Grab your Visual Studio subscription Azure account, your Azure subscription. Now that you have those, you can clone this repository, grab the security keys, follow the instructions, stitch them together, and then run the build, and it will all flow. The pipeline will be there, configured as it is in this sample. You can promote it through the environments. The environments have Azure Resource Manager, ARM templates, and the actual environments or the resources in Azure are created automatically within the pipeline because it checks, if it doesn't exist, create it. You'll end up with a 3-tiered deployment set of environments, a test automation environment, a UAT environment, and a production environment. And all of this will be set up for you. And so you follow these instructions, and these are linked. And so including the scale up and scale down runbooks, as well with screenshots and everything. That's freely available on GitHub. Probably some of you are already cloning it. If you're interested, send me an email. We have a complete walkthrough video of demonstrating all of the sequences of how to set this up. And this is the Team City version, stitching Team City together with Octopus Deploy. And it's 8 minutes and 35 seconds. So in 8 minutes and 35 seconds, you can go from nothing except your trial accounts to having this complete reference implementation fully functioning. So if you're interested, on top of the documentation that's on the GitHub, if you're interested in this video, just send me an email, say, hey, can you send that to me? And I'd be more than happy to. Okay, so let's go into the application. This is the application. I already started it up. It's running on 7174, and it is, surprise, surprise, a very, very simple Blazor application. And the only thing that I've added is just a page to grab some things from a SQL Server table, just so that we'll have a SQL Server database instead of just a web application. Okay. And inside Visual Studio, it's a very simple structure. If you've heard me speak on onion architecture at all, you'll recognize some of the dependency concerns. And let me show you what this particular application looks like. We have the core project. We have a data access project, our web service API project. We have our WebAssembly, Blazor WebAssembly client. Those all reference core. And then UI.server is our startup project. And just by definition, the startup project has to reference each of them. And I've done a separate webinar showing how to architecturally factor out the tough dependencies on a Blazor WebAssembly application so that you don't accidentally have logic in a project that's really responsible for starting up the application and by necessity has to be kind of promiscuous from a dependency management perspective. Because the project that starts an application, by its very nature, it has to reference everything in order to wire up all the dependencies. or have a whole bunch of configuration. And so our UI.server has nothing in it except for the program.cs and some other just startup concerns. The web services have been factored out into UI.api, and you can see that those are there. Okay. All right. So that is the shape of this application. And let's start with the health check, because when we deploy the application, now this is running local, but when we deploy the application, there's two things that we need to know. We don't want to rely on Octopus Deploy to say, I completed all the steps that you have defined that make up what this deployment is, and then us accidentally equate that to mean the deployment is successful. What if the deployment is successful? We would expect the application to be running on the environment that we expect it to be. We would expect the application to have started up, and we would expect all of the application's dependencies to be online and connected. And for instance, that the connection string to the database was pushed in correctly to the configuration files, and those two components are talking back and forth to each other and are happy. And any other dependencies that need to be wired up, that all of those are online and communicating properly so that the application can be used. That's what it means to have a successful deployment. Beyond that, we would also expect that the version that we intended to deploy is in fact the version that is online. And so we have two things that work together for that. One is our health check process. And so we just have an endpoint here, _health check. And if we go there, we can see, oh, this is healthy. That's fantastic. Okay. And I happen to have another environment for testing purposes that I have made unhealthy. And this is our sample production environment. So I'm going to go to health check here. And the database is actually offline. So this is going to churn waiting for the database. Then it's going to time out and it's going to return unhealthy. I'm not going to make you wait for the timeout here, but we'll see later in our monitoring. Okay, so that's healthy. The other concept is we want to know what version. And so we have another endpoint called /version. Now, running locally, it's just 1.0.0 because it's development, and that's fine. But running in a deployed environment, and I'm not going to wait the full 30 seconds for the timeout, version, okay, now we have an actual version number. Fantastic. So those are the two things that we need just to know. All right, now how does that work? What does it mean, _health check healthy? How is that actually handing it back? Because by the way, any of your IT gear that monitors uptime, it typically receives a URL and it pings it from time to time, right? So this essentially is a URL, but underneath the URL, it's actually checking some things. So let's look at that. Now, notice this line 30, app.map health checks. And there it is. This is the health check library that kind of comes with the .NET, and it works with all kinds of applications. It's not just web application specific. It works with all kinds of applications. And basically, this is what we needed to do. Now, right here, get required service. This is something that I added because when the application first starts up and runs program.cs, when is it ever just not a good idea for the application to self-diagnose itself and say, hey, I'm healthy? Now, if you accidentally put some code in these health checks that takes a long time to run, okay, well, then that wouldn't work out. But if you do it properly, you grab the health check service that is just provided by this library, microsoft.extensions.diagnostics.healthchecks, and say health check async, and boom, we're going to throw an exception if it's not. So I'm going to pull, this is the application running, and notice that it's done a few things. Let me pull this up again. And Watch this. Refresh. Boom. Okay, we have 3 health checks that it ran. I've configured each of the health checks to write a little bit of info logging. And so we have a health check in the API project, we have a health check in the server project, and we have a health check in the data access project. Typically, what's going to go wrong with your application post-deployment is that some interaction with something that is dependent is going to go wrong. You've already unit tested the code. You've already done component level integration testing that if it's connected, it does the right things. But when deploying, you are actually executing logic that is impossible to test in your integration build. And that logic is pushing in config files, taking individual deployable components and pushing them into an Azure container app, pushing them into Azure SQL, pushing into Azure Function, App Service, whatever you happen to be using, Azure Service Bus. And that cannot be tested in an integration build. So this is your first opportunity to test something. Any logic, any behavior of software that's not tested, just assume that it's broken. Okay. So any type of behavior your application has, you need to craft some type of automated test for it. Okay. So this post-deploy health check is a test. It's a test to make sure that the deployment logic did the right thing. And we push to a test automation environment every single time we do an integration build. And then we promote to UAT, we promote to production. Every time we go to a new environment, every UAT deployment should run the health check. Every production deployment should run the health check. Okay. Because every one of those has a little bit of a surface area where things could go wrong. So